Yeah, power consumption. That's another important aspect when it comes to mixing equipment, because you need the material to be converted from one state to another. Okay, needs an input of energy, and that energy is, in this case, we provide motors of a specific power. Now, how do you decide what is the power that the motor needs to have? Okay, again, I'll give you a very simple example. you know we talked about a sugar solution. So when you add sugar and you stir, it's very easy to stir. Now let's say that we have honey. Okay, and we are trying to stir the honey, okay, without adding anything. You will realize that the resistance which is offered by the honey is far greater than the resistance that is offered by water in a sugar solution, right? You require to give in more energy, there is more resistance. So in same way, industrial mixing applications, depending on the material that you are going to be you know processing or mixing, there will be a power requirement. So that could depend on the density of the material being mixed. It could depend on the viscosity of the material being mixed. And when we're doing this at an industrial scale, we need to understand that the geometry of the vessel, accordingly the geometry of the agitator, that is the mixing element, the type of the agitator, the speed of the rotation of the agitator, all of these contribute to the power required in mixing. Okay. Now, one important thing to note, that when you talk about liquids, in liquids, because of the nature of material, we are able to estimate the power required for liquid mixing applications, to the best accuracy possible. Okay, and it is well established. You can easily calculate it, what an application, liquid mixing application, the power required, and selecting a motor horsepower. It gets difficult in solids, okay, because solids really don't behave like liquids, and that is where the material characteristics play an important role. And when you talk about high viscosity materials or non-Newtonian materials, then it's extremely difficult to model such systems and to have equations which will give you the correct estimation of power. And that is the reason, in the beginning we said that mixing is an art as much as it is science. But the fundamentals, the parameters that are going to be affecting the power consumption, so type of agitator, mixing blade, the sweep diameter of the agitator, the speed of rotation, the vessel geometry and attachments, the density of the material being mixed, and the viscosity of the mix. These are factors which achieve the power consumption, and it's an important aspect of the design of the equipment.